Here we will look at a probability question involving combinations. A chef is choosing from 12 different entrees for a banquet, and 3 of the entrees have spinach. The guest will have a choice of 4 entrees. They're choosing 4 at random, and we want to find the probability that none contain spinach, or at least 1 has spinach, or 3 have spinach, or all 4 have spinach. So let's look at the first situation. None have spinach. If we have 12 entrees and 3 have spinach, then 9 have no spinach. We're choosing only 4. So the way that we want to set up the events for picking no spinach is we're going to set up a combination for the number of ways to pick no spinach and the number of ways to pick spinach. So we have our spinach. Now there are only 3 spinach entrees, so when I set up my combination, 3 is my total that I have to pick from. And if I don't want spinach at all, then I'm picking 0. So 3 choosing 0 would be the number of ways to choose 0 spinach entrees from the spinach entrees. Then we have the ways to pick no spinach, and there are 9 entrees that have no spinach, and if we are picking none with spinach, that means all 4 will have no spinach. So 9 choosing 4. So we have the number of ways to pick spinach, the number of ways to pick non-spinach entrees, and the fundamental counting principle says to find the total number of ways for these events to occur, you find the product of these ways. So we multiply these combinations together. Notice that the left side numbers of the combinations add up to 12, which is the total that you're picking, and the right side numbers, 0 and 4, add up to 4, which is the total you're choosing. Since it's a probability, you want to divide these by the total number of ways to pick the number of total entrees out of the total available. So on this denominator, it's a single combination. The left side number is the sum of the left side numbers up above, which is 12 total entrees. The right side number is the sum of your right side numbers, 4 that we're picking, 12C4. I would use a calculator to evaluate these because you're doing multiple combinations. So there is a formula that you could use to evaluate combinations, but you can just use your calculator and use your NCR program to determine what these answers are. So 3C0 is 1, 9C4 is 126, and then 12C4 is 495. So I have 126 out of 495 that I want to divide now. And that's equal to 0.255 if I round that to 3 places. So that's the probability for the first option. Okay. B, I'm going to come back to that. That's a little bit more multi-step. Let's look at C. 3 have spinach. So set it up the same way we did here. Let's look at the number of ways to pick spinach, the number of ways to pick non-spinach entrees. So we have our separate combinations. So the left side number for the spinach, I have 3 spinach to pick from. And if I want to have 3 spinach, then I'm going to choose all 3. So 3 spinach to pick from, choosing 3. Now remember that we are picking 4 total entrees though. So that means if I'm picking 3 with spinach, then I have 1 entree left that's going to be a non-spinach. And how many non-spinach entrees do we have? There's 9. 9 choosing 1. So you can check your math by making sure that the left side adds up to 12 and the right side adds up to 4 each time. The denominator is always going to be 12C4 for this. So 3C3 is 1, and then 9C1 is 9, and then the denominator 12C4 is 495. So we have 9 divided by 495. And that's equal to 0.018. D is all 4 have spinach. So we have the spinach, we have the non, So when we set this up, the left side number of your spinach, remember, is the total spinach entrees that you're allowed to pick from, and there's only 3. Now this option says all 4 have spinach. It's not possible for your right side number to be larger than your left side number. It has to be equal to the total or less than the total. There's no way to pick 4 spinach entrees because there's only 3. So this is an impossible event, and the probability of an impossible event is 0. So now let's go back to B. Find the probability that at least one entree has spinach. Well, at least one means we can pick 1 spinach or 2 spinach entrees or 3 . So at least 1 spinach is 1 or 2 or 3. Now remember that our limit is 3 spinach entrees. So we can only go up to 3. So we can't do 4 or anything higher. So at least 1 is 1 or greater, but you have to max out at your total. So I have found up above, I found in part C the probability that we have 3 spinach. I've already found that out, is 0.018. So I'm going to bring that down here. That's 0.018. I've already worked that one out. Now the others I do need to set up. So the probability of getting 1 spinach, so I have my spinach and my non. So I have 3 choosing 1 spinach, and I have 9, and then I have, remember you want your right side numbers to add up to 4, so 9 choosing 3 of the non-spinach over 12C4. So 3C1 is 3, 9C3 is 84, and then 12C4 is 495. So multiply 3 times 84 and you get 252 out of 495. So 252 divided by 495 is 0.509. So this probability is 0.509. Now the probability of getting 2 spinach. So now I have 3 choosing 2, and my non-spinach is 9 choosing 2. So the left adds up to 12, the right adds up to 4, and that's divided by 12C4. So solving for those combinations gives you 3 times 36 divided by 495. So this is 108 divided by 495, and that's 0.218. Since this is an event where we're wanting to find the probability that at least 1 occurs, then in this situation we can add these probabilities to find the total ways, since this is an OR. So add up all of those answers to find the total result. So this gives you 0.745.